This week, we are going to deal with a winch example. Our example is in US Imperial units and style. First of all, we are going to change these style by just moving the views according to ISO standards, which is the first angle projection. We take the top view to the bottom side in order to change the view from imperial standards to metric standards. You can also see the converted image in your submission. In our example, we have three views. One with the assembled view and two detailed views. Some coursebook gives some examples as shown on the screen. And these examples are called assembly views. And these views made us to think about the possibilities of the parts which we will just assemble together. In our assembly, we have two views. One is the front view and the other one is the top view. You can see these views on the screen. Let's analyze the assembly parts from the assembly view. In this analysis, we are going to name the parts, find the quantities, and just define their materials. Our first part is the body part, which you see on the screen. The material of this part is steel, and its quantity is 1. This part will be modeled with the sheet metal properties, and we also have the flat pattern of this model. Our second part is the handle part. It is a sheet metal modeling part also. You can see the top view and the front view. The material of the handle is steel and the quantity is 1. We will also create the flat pattern of this model. Our third part is the actuator shaft. Its quantity is 1 and the material is steel. Our next part is a welded subassembly, which is a gear cover. It's a welded assembly and consists of two parts, and its quantity is 1. The first part is a plate part, and the second one is also a sheet metal part, which is just covered around that plate. Our next part is drum weld assembly. This assembly quantity is 1, and welded assembly consists of gear, bush, side plate with hole, and side plate without a hole. Our next part is drum bush. Its material is steel and its quantity is 1. It is inserted in the drum weld assembly. Seventh assembly component is a pinion gear. Its material is steel and its quantity is 1. In a geared drivetrain, we name the small gear as a pinion. Eighth component in our assembly is the actuator bush. We have two quantities and their material is steel. Our ninth component in our assembly is pole. Its material is steel and its quantity is 1. We use this pole in order to control the direction of our winch. 10th part of our assembly is a spring holder. Its material is steel. Its quantity is 1. It's a sheet metal part with banded properties. The next part in our assembly is handle pin. Its material is steel. Its quantity is 1. Our next part is handle bush, and it is a steel part. Its quantity is 1. It is mounted on the handle pin. We have finally reached our parts in the assembly. Let's talk about our standard parts, which is mounted on our assembly. We have two bolts with 0.375 inches. We have two nuts with 0.375 inches. We have a nut which is 0.5-13 UNC. We have two washers, one K and one retaining ring. If we prepare a part list of our assembly, we will have this result. And in this part list, the only thing that is the missing part is the bulb lengths here. We will just define these lengths by just calculating face-to-face distance of our parts in the assembly. And here we get a result like this. This week we are going to make the parts one by one. The first part is our body part. Components are attached on it. We will just have a general shape which follows like this. I will just overwrite the outline which you see on the screen. And we are going to make this part sketch first. Then we will just make the extrusion. We first design the parts. Then we will just add the sheet metal properties. In Autodesk Inventor, we create the sheet metal parts with two ways. I will just show the two ways in this example. First, we just create the part with the sheet metal properties from the default. For this, I will just open a new part. Start a part with sheet metal, and I will just reach that position, the default template file, from the ENUS metric and the sheet metal properties which you see on the screen. With double click, I will just start to draw my part. As you see on the screen, we have an open inventor file with the sheet metal properties which you see on the top side. Also, we have a tab view on the other, which is on the other file with the sheet metal properties, sheet metal features. To show you the difference, we also have the 3D model side on the other tab, I'm sorry. Also, we have a standard millimetric template file, which is this one, which is almost the same identical tab here. Okay, I will just start with the inventor modeling. My part is in inch units, imperial units. For this, I will just open a new part. This time, not I'm going to use, but you are going to use the metric templates because I will just create the drawing views in millimeters, which I'm just going to add your submission. I will just use the English units with sheet metal inch IPT. I have just double click on it. The first thing, what I'm going to do is I will just create a base view, a base face, which is on the bottom side. I will just draw that base face with this rectangle. I will just create, which I have seen from the front view, and this base have a figure something like this. I will just create a face and I will just add this sideways which I have, which you see on the screen. I will just create the base view and I will add the side walls to my figure by using a special command, a flange command. Okay, let's start. Our rectangle is, we have the thickness value here, we have the length value, and we have the total face width here, which is this one 4.2 millimeter, and here we have 0.38 inches, I'm sorry, 38 inches with included with the thickness here from wall to wall. We first make the wall at this point. Also, you can see at this point we have the thickness which is this 4.2 inches, I'm sorry, and 0.1 inch after this wall side. You see, we have a dimension between the two walls here. I can just take that face width from the top side, which is 4.3 millimeter. Let's just draw. And as an origin point, I can just use at any point in my drawing. For this example, I will use this face from the front side, this edge, this corner, and this corner as my origin, which is this point in the middle side. Okay, let's minimize. The first thing that you should do is please set up your sheet metal defaults. From this one, I will just adjust my sheet metal thickness from this point. And please just untick this one and open. I have opened my figure here and have this part 0.188 inches with this thickness. I will just start modeling with this value. I'll change the thickness of our sheet metal part. First start with this is changed. The next thing, I will just open an XY plane, start a new sketch, and get this corner, create a first rectangle, which I have seen from the top side. I will just first create this face. I'm sorry. Back. I will just create this face from the top side. Okay. As you see, from the wall to the wall, we have 0.10 inches, which is 4.3 inches. 4.3. Also, the width, which is 6 inches. I will just create first the base, here. This length I'm interested in. Go back to model here and make this midpoint I get, make this one coincident, this midpoint coincident to origin point. Finish my sketch and have the face command here. The face command is very important because, as you see, we are face the point which we have selected as the origin. Let me again make it visible. Have the face command. As you see, our face is bottom face just touches on XY plane. As you see, we have no extrusion at this point because we have already adjusted that extrusion, the material thickness, the sheet metal thickness with this sheet metal parameters. I have the first face here. The next thing, I will just add the wall sides, which I have seen in the technical drawing in our front view. I will just add this wall. For this, I will just add a normal wall here and I will just make the cuts which I have seen. I have just marked at these points. I will just erase these points. For this, I need a sketch on this. But first of all, I need a wall from the sideways here. The next thing I'm going to do is I will just create the walls by selecting the flange command here. I'll just select this face. As you see, it is just bended. We just create this part with bending methods. And here, I would like to just change my direction from top side. Also, I will just create another face, another edge to create this one. Also, I would like to have a distance constraint. I can just make this one. And this is the inches here. I will just extend this one by clicking the command. I will just extend as much as I can. But checking is better here, the dimension, which we would like to have this one. It is much more than, which is 3.8 inches. Also, I will add this curvature, which is this arc shape, which is 0.6 inches. If I have just add these two to each other, I will have 4.4 inches at least. Let's make 5 inches more. Okay. We have the side walls. But before controlling this one, I'll again just turn to the top view and I will just check my dimensions from the inspect tool, which you have seen here, the measure tool. I would like to have the inner faces of this U shape, which will be 4.3 millimeters inches. I'm sorry. For this, I need to do something because I have just created my edges. As you see, we have just created these bends at this point, and I would like to have that bends away which are starting from this point, or I would like to have the same amount here. This is the 4.3 millimeter inches distance between these sides of these faces. As you see, we have just captured that length by using the bend position, which is the outside of bend extents. As you see, we have the material thickness added to it. We have first create the walls. Again, we just measure. I will change my orientation view. I select this face, the measure tool, then the other face, which is this one, to show you that what I have this, as you see, we have 4.3 inches in distance between the walls of our part. Let's save our part file, which is the part file 1 file. Please also create a new folder under the desktop with a Winch folder. Okay. Okay, we continue our part. I have just divided my page into two groups, and in this one we have the technical drawing, and other window we have the inventor model side. We have just created our part body especially, but we are going to just shape our body part by having the extrusions with cut operations. For this cut operations, we need some sketches, and we are going to use the dimensions which are given in our body part in the technical drawing. For this, we first have to just create the part axes. Here we have one axis like this. We have the principal axis, which we have the objects dimension details. We will just define, and then what we are going to do is we will just make, let's have a bigger one, we will just make the cut process in order to give the shape of our part. For this, I will just turn back to my piece, my part. From this view, I just get the bottom view, and I assume this view is my front view, which I'm going to use in my model. I will just take it back. First thing, I can just even create my sketch at this point, or if you want, you can use this face for starting a sketch. But to be much more better, if you want, you can use the XY plane, XZ plane, I'm sorry. I have opened this visibility with F7 tool. I will just cut, and I will just continue to create my axis lines, which I have shown 3 of it. Also, I have some other axis lines which is on the bottom side. I will just create 4 axis lines in order to create my figure. I will just create 4 axis lines like these small. This represents this axis line. I have convert them to construction, made them midpoint to midpoint constraint. If you want, you can have the copy and the paste command, and you can just move your parts this sketches. You can just create again another copy. You have this one. I will just move again, take it back. I will just move the second one. This is my, okay, a little bit more. I will move also this one. Again, I have another small one. For that, again, I just create another copy with right click, a paste function, and I will just move my part to the place where I will just use my axis lines. Okay, we have 4 axis lines, 1, 2, 3, and 4, which I'm going to just use the basic of these parts. Okay, from this point I have the first one. Let me have this one. I have a distance from the bottom face, which is from the bottom face. I will give a dimensional constraint which is 3.8. The next thing, I will just use this dimension 2.4. These are in inches unit. You will just make these in metric units. I will just convert these dimensions to metric units. This one we have 1.6. I will just take my dimensions from the paint. 1.6. Okay, I will reshape my mouse figure here, somewhere here I will use. Okay, fix it this point. Okay, fix that one. The next thing, I have this dimension relationship, which is 0.34. 0.34. 0.34. I'm sorry. I will extend this dimension, and I have the distance relationship from this small hole, which I will just hold this one. This is 0.5, and from this one I have 0.4, which is this figure here with radius. I have a radius relationship like this. I have a radius relationship at this point, which is I'm going to use this one, having the radius here 0.4, and I will make this dimension stick to this edge, and I will also give the dimension relationship, which is this one. It is 4.01 millimeter far from this line. Okay, again I adjust. From this point we have another dimension relationship, but this dimension is not the linear dimension. We have a shortest way distance. For this I will use another constructing method. I will use a circle having the dimension. It is the same, which I will just connect these two lines to each other, having the dimension which is 3.75. It is the same. If I do not use a line here, I can just make this dimension with the radius 3.75, and I will just make this point on this circle. Also, just take that back. I would like to have enlarge this line because I need the intersection point. Also, I need this point on this curve and this point on this curve. Yes, I get this distance, and I will, if I just make the measurement here like this, as you see, because I have already done that one. If you want, you can use the same thing. Let's take this one back. I will leave as this reference dimension. The next thing, I will just create the outline for cut operation. I will use a curvature which I have seen at this point, and that curvature from the example we have 0.6 millimeter. It's just covered, but it is 0.6 6. I will give the radius here 0.6, and I will just connect these two items, this one and this one, having a line with tangent constraints, and make them trimmed because I'm not going to use the excess bars. Also, I have another line which just goes to, let's just goes to up to this point, which is again a line, and I have made this line and on this point, and I will just make a tangent relationship to fix that part. Okay. Also, I will just use circles, and from these circles we have some bolt passing here, which is 0.375 and also 0.375, and also we have a bushing at this point, and I will just search its dimension from this point, which is 0.75. I will just create the dimensions, the diameters which I will need. I will trim this operation because I'm going to use the top side extrusion cut. And also for cut operation I need these two lines. In order to have, I will just create a closed loop around this point. Also I will just make the trim, also trim, give the dimensions. These two circles, this one and this one, are equal to each other, and we have 0.375. Also this one we have 0.75 for bushing part. Okay, I think we have done most of the things. Finish my sketch. This time I'm not going to use any commands here. I will use the 3D model commands. As you see, we have the extrusion tool. What I need is, I need the profile here, which is just touching these points. Here I think I made a mistake. Just stick to it, F7. I will just look for this point, make this line. I will make this line passing from this point. As you see, we have an open circuit here. I will just define that line again. Finish my sketch. I have the extrude tool. This time I have the profile, but I need a cut operation with symmetrical through in all directions. Also I need additional profiles, which is this one, and this one. Also I have forgotten one hole here, and again I will add that hole with F7 tool, which is this one. I have forgotten the spring holding tool, which is this diameter is 0.198. Again I go to this point, I add the dimension here, which is 0.198. Finish my sketch. Again I will make this visible to use it again. Have the extrusion tool. This time I will just go and add that point again. I will just make this extrusion and just add this feature to our part. This is our part. Okay. Have this one, make it invisible, and save our part. We will continue to make the top view details, which are these slot hole and these 3 holes, which we have. Okay, I will just add. We have a slot hole at this point. As you see, we have a slot hole at this point, and we have 2 holes, 3 holes at this point. It is on 0.5 millimeter on this line. We will just create 3 holes. I start the sketch on this face. I create a line, and I'm not going to use this line. I will create 3 axis lines, just arbitrary. I will just stick them to my part view. We have 1 inch hole, and this at the middle point we have, I'm going to use this axis which is passing from the origin point. I will just make this line, stick the origin point, and give the dimensional relationship which is 1 inch here. I will just extend, also give this distance relationship which is 0.5. Again 1 inch from the midpoint, which is again 1 inch. And I will just convert these 2 lines to construction, and I will just define 3 circles. Which one? This one, and this one. Make them equal to each other. I will use this one and give 1 dimension. It will be enough. And here we have the top side. We have 3 holes, which is 0.1, 0.406. I will just define 0.406 and make these equal to each other. Also, I cannot just stick to this one. Again, I will make this circle and this circle equal to each other. Also, we have a slot feature. For this, I will use the rectangular tool. Here, my slot have 1 dimension. Again, the same size, whole dimension, which is here 0.406, and it is 0.5 inches far from this end. Also from the other side we have 1.4 inches with length. Here what I'm going to do is I will just define these inputs, which I have these 2 lines. This is horizontal, vertical. Convert these. First create the slot here. It is not very important. If you want, you can use this one or this one. I can use these 2 items. The first one, I will just define the dimensional relationship, which is 0.5, and from this point to this line it is 1.4. Again, the radius here, these are equal to this one, but I will just like to have that dimension also. For this I will just define and make tangent for 2 sides to each other. This one to this one. Okay. Finish my sketch. The next thing, I will just create the extrusion cuts. Normal basic tools I'm using. This one, this one, this one, this profile. From the top side I have this one and this one with cut through all. Let me check if they are cutting. Yes. Finish my sketch. Finish my command. This is, I will just save the body part. This is our body part. This is our body part, the crane body, winch body. And here what I'm going to do is I again have this body part with the sheet metal properties, which is we are going to manufacture with this pattern view. I will just create this pattern view and I'm going to use this pattern view in the technical drawing in order to define the band axes. For this I will just click this one. I have the pattern view, flat view. I will use this one. In order to go back, you will just go to folded part here. Finish this one. Have this one. After this one, we are going to just make the technical drawing of this body part. Okay. For our part drawing, we are going to continue by starting a new part drawing file. For this, in our example, I will use a metric with ISO standard IDV tool, although our part is in inch units. I would like to just create 2 pages of this sheet, and I will use that pages for other applications. For this, I will just create a new file, which is a Winch technical drawing file. And I would like to have 2 pages. One page I'm going to use for the assembly drawing and the other page for the technical drawing of the parts. And for this, I will just like to edit my sheet and increase the size to A1 sheet. This is the A1 sheet. And I would like to just start by creation of the base view, which is our body part, which is this one. It's already open here. As you see, at this point we have a folded model at this, and we have a flat pattern. We just create the first base view with the folded model, and I would just like to have the scale to 1 to 5, because let's say 1 to 2.5, a little bit bigger scale, like this. And I would like to have all the dimensions, and I would like to have all the views. I will just have selected and make a projection view, which I have seen from the front view. I create this one. From the projection, I would like to create a projection view. Also, I would like to add a flat pattern for manufacturing processes of my part. By having these, also you can have these options if you want so. Let's create. As you see, our base view has the hidden lines open. If I would like to just change my view without the hidden lines, I may have a view something like this. Let's open again the hidden lines of our part here. The next thing, what I'm going to do is I will add the axis lines to my parts. this one and this one. This is not very clear. For this reason, I will just, for this whole hidden lines, I will just like to hide from this one. It is locked to the other property of this line, and I will just make this line removed from this view. I would like to have the hidden lines removed from this view. With click OK. I would like to only have some dimensions about this. Again, I will just retrieve the model annotations, the dimensions of our figure here. But before, I would like to have change the style editor, which is default ISO. Instead of decimal marker, we use period. We use the precision for 3 digits for linear and angular dimensions. And I will just like to have unticked because I do not want any leading and trailing zeros following my dimension text. The next thing I would like to have, again, a tolerance here. Increase the linear precision, also increase the angular precision, and I will just close the leading and the trailing zeros of this part. Okay. The next thing, what I'm going to do is I will just bring the dimensions which I have needed in my view. I have OK. I will just select and arrange as much as I can the dimensions. Here, this dimension, here, this dimension. I will just arrange my dimensions according to the figure I would like to keep. The dimensions outside of my part and take these dimensions close to the area which we are going to use. I will just delete this one. Also, I would like to delete the 5 inches extrusion length, which the flange dimensions. The other one, I will just extend and touch this line. Also, we have this. I would like to have, again, this is the same dimension, which is this one. This is the small dimension here. We have a sheet metal thickness at this point. I would like to show in another view, which is the left side view here. Delete this one and adjust the dimensions as much as we can. Also, I would like to have the other dimensions. For this, select this view, then select the retrieve model annotations with apply and OK. For this, we have this view. We have 2 inches. Also, we have extended a line here. Yes, exactly. Also, we have another line here. I would like to have this view. Also, I would like to have the material thickness. And we have 90 degrees, as you see, the bending, and this is the bending radius, which will give information to its manufacturer or the master, or the worker, which it is going to deal with this figure. Also, we have 7 to 1 inches distance. For this, I will again try to add this one. It is not very clear. I would like to have this dimension by manually. from this point I do not need this one. I have this angular dimension. Also, we have a flat pattern view, and do not forget to make this one with the writing the scale to 1 to, let's say, 2.5, I think it was. Please check this scale because it will be 1 to 1 when it is just manufactured. You cannot use this scaled version in manufacturing processes. And these are the lines which the worker or the operator are going to use for bending purposes. And here I would like to have those dimensions from this point. I would like to give some information about the manufacturing of these parts. Also, because these are the developed length. Also, from this point we have the total length. The width of the part is 6 inches. Just gives these dimensions the idea about its manufacture. And also from here, this point, I would like to have the bending. I would like to tell the worker about the bending issue about this section. We first select bend command for annotation. We just end this one. This is the down to 90 millimeter to inside with the radius which is 0.188. Again, the same thing for the other axis. We can just change this one. It is going to be bended. This part will be bended into this point here. I would like to have just close some visibilities of our parts like this. Anyway, okay, this is all for our part. If we need more examples, we will just make more dimensions that we need to. We will just give. It is better to move this dimension to this point. Also, again, for this one, I would like to have those dimensions about these points. Yes, it will be much more beneficial to use these dimensions by adding the lines to them. Yes, again, I will just move and extend to this point, having these. Okay. It is much more clear than this one. For this, I would like to add axis, which gives us the dimensional things. Also, we have some other axes from the top side. I will just extend these axes. This is our part drawing process in our figure. This is the second one. I'm sorry, this one. I will extend. If you want, you can just use one which will cover these. I will just delete this one and I will extend this one. Also, for this one, I'm going to make another. And here, I think this circle is the center of this one. Let me check the dimension. It was 0.4 inches from the back side of our part. I'll just make this one, stick to it to give the dimensions and I would like to keep that dimension outside of my part figure. Okay, this is all for our part drawing for this one. I create a sketch to the sheet. For this, I select the sheet, then start a new sketch, and I will just draw an outline for my part drawing, and I will just adjust this one, change the line property from the normal part drawing. I will use something like this, a long dash double dot. With this also I need to add a text, part 1 body, to have imply it's a sheet metal band. Okay, this one. Okay, if you want, you can increase the font size by selecting the tool, selecting the text, and just increasing this one. You can also, with enter, you can also change the font type from here, but it is better to use as it is in our level. It will be enough. I'll just double click and just reduce this one with this. This is the scale of our flat pattern view. Let me move. Also let me move this text as well. Okay, this is all for our part. Okay, we continue with our second part, which is the handle of this winch. This is also a sheet metal bended part, and we will just start our modeling of our part from which you can see on the screen. I will just first draw the outline here by following the dimensions of our part. And this part creation, during this part creation, I will just draw this outline, and I will just make a 1-inch extrusion, which you have seen here. Let me draw this again, which you have seen at this point, and I will just make the shapes and have these holes, hole features, which you have seen here. One is at this point, the other one is at this point. We will create that details later on. We will just start with our part. This time we will just we design our part with the 3D modeling techniques, and we will convert our part with sheet metal conversion. For this, the first thing, I will just create my part here. Yes. Let me see one more. We have a Z shape. I will just follow that Z shape, and I will just select one point, which is, let's say, this point as my origin point, and I will just create the part file by using around this point. Open a new file from this point. Again, English units with standard inch. I'm not going to use the sheet metal properties. I'm going to use the standard part here. The next thing, I will just open center point visibility and XY plane visibility. And this is my top view, which I'm going to use this plane as a front view. And we will just consider a new sketch. I will use on this point as origin for our part. For this, the next thing, I will just follow. If you want, you can just draw the lines, but I prefer to make the rectangles between the parts like this. And I will just make the trims for unnecessary parts here, as you see. Then we will just give the fillets which we have seen here. Okay. The next thing, I will just define this point, this dimensional relationship which you have seen in our part. It is 0.75. And the dimension from this point to this point, which is 1.5. I will just rearrange my figure to be in the same shape. The next thing, what I'm going to do is, I will just enter the sheet metal thickness with 0.25. And I'll just make this line at this point. Again, this will follow the same length here, which is 0.25 again, which is 0.25. And from this point, I have 9.5 inches, this distance. And I will just create that distance from this point to this point, which is 9.5 inches. And I'll just take out my view and make it a little bit clearer about my figure. As you see, we have at this point, we have a height measurement from this point, this line to this line, which is 1.2. As you see, our figure have all fully defined lines, which their colors are here, the part these. Okay, finish my sketch first of all. The thing, what I'm going to do is, I will just create a symmetrical extrusion. Also, this is my origin point, and I will just create a symmetrical extrusion with 1 inches. I have get an extrusion. I will just create an extrusion process with 1 inch, but this time I will try to keep this origin point inside. Okay. The next thing, we have these cuts. If you want, you can make these cuts later on, but if you want, you can make right now or later, You can have, we are going to make a extrusion cut, which is again passing from this point with the radius. This time we have a radius dimension type, and it is 0.7, and this curvature just passes at the end of these 2 points. We will just make coincident these points on this point, also on this point. Yes, it is passing, and I will add this addition here. Also, I made a mistake. You can also make tangent to this point with the curvature, which is this point and this point are on the same line. I use an aid line, a horizontal one, and make coincident this point on this line. I will just make the trim because I'm going to use only the top side of it. I'll just get the geometries, this line and this line, and I'll just make the trim for unnecessary portions. Do the same thing for the other side. I have the same operation. Again, get this geometry, create a line, with F7 tool. I have created actually at that point. F7, we will just create a line from this point. It is not important. I will just convert it to construction. Also with F7 tool, again I take that back with top side, bottom side, and I will just create a new circle coincident at this corner and tangent to this line. I'm sorry, let's change the order here. First the tangent, then again I will use the equality of these two circles. With F7 tool, I will just reserve this quarter circle area like this. Finish my sketch. Change the orientation view. Have the extrude tool. I will just get these corners, also these corners, and make a cut process with symmetrical through all. I will just make the cuts one by one. The next thing we have, we have a hole at this point. You can also make this hole by the hole command, which you see here. I will again redefine that hole. We have 0.5, which is this, not passing from that point. Also we have some other details. Let's leave it later. Okay. I'm sorry. Just take my mouse back. Okay. The next thing, what I'm going to do is, I will convert my part to sheet metal from this point. I have this tool. This time, as you see, in the previous example, we have the sheet metal properties. Again, I can also use the normal 3D modeling commands, but this time, when I have just start this time, the converting to the sheet metal properties, I have the sheet metal properties. From this point, what I'm going to do is, I will just first define, as usual, in the sheet metal part here, I will define first the thickness of my part here. And it is, as you see, we have 0.25 thicknesses in this handlebar. Make this check unchecked and change the dimension. It's 0.25. We have the thickness. Please do not change this one because the development or the bending sections are automatically displayed. If you do not know, if you do not have the K factors in your production, please just do not change these parameters. The next thing, I will add bend sections here. And this bend section will add this bends, the unfold rules and the sheet method rules by default, not by using these fillets here. I'm not going to make the fillets around this 2 points, 2 bends. We have 2 bends here. The next thing, what I'm going to do is I will just bend the edge, which is this one. Also bend the other edge again, not this one. Let's say just create one bend inside the other bend on the other side. Let's one by one again add another bend to this point. As you see, we are going to use the default factors. Here we have the bends in our part. The next thing, what we did in our part here, I'm going to save the part 2 handle, and this time the next thing what I'm going to do is I will create a flat pattern view here. Let's have this one. As you see, we just created this flat pattern model at this point. To go back to our modeling, we will just go to our modeling section. Okay. The next thing in our part, we have a threaded hole at this point, which is here, and also we have a hole which is at this point. I will just take my mouse back and just create a hole feature here. For this one, in our part, we have a hole which is 0.312 with dash 18 UNC at this point, which is 0.5 millimeter far from this end. For this, I will just use the normal 3D model properties. Again, I will start a new sketch at this end, and I will just create a line, actually 2 lines, and create one for whole sketch, and make these 2 lines, the first line tangent to this one. I'm going to just make this circle just for creating the whole location, this point I need for this whole creation here. This is the axis and this is the axis point of that hole. Here I'm going to just define the distance, which is 0.5 inches far from this end, which is, I will just zoom in to show you better. This is the 0.5 inches from the end of this part. This is the end of this part. You can also make this hole with the revolve feature, then thread it. It's up to you. For here, the next thing I would like to fix is the point on this line, which is passing at the midpoint of our feature. Here I will just create an edit line here and make this point coincident on this line. Have the coincident constraint this point to this line. I will use this circle only for that circle center, actually only for the whole location point. Finish my sketch. I have the hole tool. I create a threaded hole with through all properties with the NC unified screw. It is the UNC, but this time my size is 0.25. I'm sorry, not 25, 0.312, which is this one. With it is actually 5 to quarter, 5 to 16 with 3 UNC part. The next thing, I will just choose the point and the surface here. I have this point, as you see, it is directly to inside of our part here. And I have the full depth thread, which I am not interested in this feature. I have the full depth. And I have all the dimensions here. Finish my hole here. I have this one. The next thing, the next feature which we are going to create is this whole feature here. We have this whole feature. For this, we need a passage here which is 0.5 inches. For this one, I will just create this hole with extrude tool. It is not threaded this time. I will just make a cut with through all operation. For this one, I will just create a hole. Here we have the model side, and we will just save our part. This is the part modeling side. For this, on the other side, we have the, if you have the technical drawing, we will just place the view with base and just choose our handle part. And I have this part view, also this projection view, with right click with OK. Also, what I need is, as I have did in the first body part, I need a flat pattern of our part. Let's have this one. I have created this flat pattern here. I will extend with double click the sketch attached to the page here and draw the borders of our handle technical drawing. Finish my sketch. Here what I'm going to do is I will just retrieve first. I will retrieve the dimensions. If you want, you can just make a sectional cut. This time I create a sketch attached to this view. I will just make the select, start the sketch from the technical drawing and select this view. This is highlighted as you see, and create a full rectangle which we tell the software what to cut and what size to cut. We will just cover all this area to be cutted to up to a point. We have placed a breakout view. Select this view. As you see, we have just this profile to be cut up to, this time I'm not going to use the from point tool, I will use the hole tool, which passes at this point. And as you see, we have defined two requirements here and make this cut as usual. The next thing, I will go to the annotate section and create the axis lines for my figure. The next thing, I will just create the access line for holes here. And in the production of our parts, we just create the parts at this point. Here we are not interested in the cuts. If you want, so you can just omit, select these tools. For example, this hole tool will be only marked, can be only marked, but it is not a threaded hole during this cutting process. And we will just close these tools visibility by selecting first with right click, just choose these hole feature removed. The next thing, I just create the line properties here. I have the tools, also other dimension properties. I select this one. As you see, we have some inch dimensions with metric conversion. I will just delete this dimension, which is the whole dimension. Also, I'm not going to use this dimension at this point. If you want, so you can have the thickness of our material, it will be needed for production. Also the inside radiuses, which tells our operator to have the tools that he must use or she must use. Also, I will just leave this line with properties here. Also, I have to define the bend nodes for manufacturing processes. The bend will be upside, this bend will be downside, by using the tool which is R20 0.25, and we will need a material to be total length, which 306 millimeters, approximately 7 millimeters approximately. Also, we have to define the two bending dimensions defined from different edges, because when I have bended this bend, then the part will just disturb and I cannot define these two dimensions. If you want, you can also make another dimension, but it's not needed. It's better to give this dimension from this side. Also, I will just use the copy here. I'm not going to create and paste here. Change the part description with 2 and handle. And this is our second part. We will continue with our third part. We continue our part modeling with the shaft part, and this part length is not given in the assembly drawing. We will just calculate the length and the missing dimensions in our example. Let's start from the bottom side. From the bushing till to the inside of our body part is 0.2 inches. And after that point, we have 4.2 inches far from the tail to the gear side. And after the gear side, we have again 0.2 inches. Also, our thickness of our body part, which is 0.188. From that point, the dimensions are not very clear. If you want, we can just add 0.2 inches from the inside wall of our body part till to the bushing side. And after that bushing side, we have a handle thickness, and after that handle thickness, we are going to just add a 0.58 inch knot part, and after that one, we have a little thickness around that one, and we can add 2 threads of our shaft dimension. Let's add them all together. We have 2 dimensions to be specified. The first one is the key dimension, which is between the pinion gear and the shaft size. The key dimension is shown on this table, and these dimensions are just shared between the hub part and the shaft part. The necessary dimensions can be calculated with these formulas or with the given tables. With the given values, we can calculate the S value, which is shown in this picture. The next missing dimension is our retaining ring dimension and its location. The retaining ring dimensions, we calculate and find their dimensions from the tables shown on the screen. We have 2 types of retaining ring, internal and external. In our example, our retaining ring type is external ring. For this reason, we will use the table on the right side. In this table, we define the groove dimensions on our shaft according to the shaft diameter, and groove dimensions also have some tolerance values. We will use those tolerance values in the sketch. There are also other dimensions which are specified on the table, and these dimensions we use during our modeling. In our modeling, our diameter is 0.625 inches, and the groove dimensions are 0.588 with plus minus tolerance 0.03, and the width is 0.039 with plus 0.003 inches. Let's start with the modeling of our shaft part. I will just open a new part file from standard Winch IPT. As we made from the calculations which we made before, we can use 2 ways in this part drawing, in this part modeling. We can use by adding the extrusions on and on, or we can just use the revolve technique. I will use the revolve technique because we have some features. Also, we have to revise some parts of our model with this technique. The other side, the other technique, the extrusion on and on technique, will not be much better for this reason. I will just choose this point, this point here. I will use this point as my origin point. I start a new sketch after this one on XY plane. The first thing, in the cylindrical parts, we just create a line and convert this line to centerline properties, which is this gives us the diameter information about our part. The next thing, I will just use and just follow this profile. I will just open a new part. I will just follow the profile I'll just follow the profile by creating the lines this time. I have a groove at this point, and I will just go up. Also, I have a step at this point. Let me take back. From this point, I have a step. Also, I have, this is the groove. Also, I have a key at this point, and after that key we will just continue with this step till to the upside here, and I will just return to the origin point back from this figure. I will just go back here. What I'm going to do is I will just make the line which I have drawn on the paint. This time we have a groove like this. I will just stick to this point because it just goes inside and outside, and I will have the same dimension. As you see, we have attached this point. It is very important to get that relationship. Also, we have the perpendicular relationship. I will just go up, and I will just from this side we have a step at this point which is further than this one. I will go up till this side, and I'll turn back to. If you want, you can also use this line, center line, because we haven't turned that line to construction. We can use this line for other purposes. Also, I have just forgotten, we have another step at this point. I will just create that step, and I will just trim the unnecessary parts. From the other side, I have just started with this dimension, which is 0.625. okay, this dimension 0.625. also, this dimension I do not know here, but I can just, we have calculated, which is 5.5 inches for all. And also, we do not have this dimension, but we, from the previous our calculations, we have 0.20, and also we have at this point, as you see, 0.1, and here I can tell that this dimension is going to be 0.3 inches. I made a mistake from the previous section. I will just correct it, this retaining ring dimensions. From this dimension, I will just go and find this dimension. Our groove size will be 0.588 with diameter, with plus minus tolerance with 0.003, I'm sorry, and the width is the same as which we have calculated or find from the size of the shaft, 0.5. I will just define this dimension, and this dimension, as you see, we have the groove, which is 0.588 dimension. Also, to have the properties on the others, on the technical drawing side, we change this property and give the plus and minus sign here, the precision here, the tolerance value, it is a symmetric value, and we get that value, which is 0.03 inches, which will be shown like this in the technical drawing. The groove size is 0.03, and I will add that dimension, 0.03, 003, I'm sorry. This is, I am sorry, 0. I made a mistake, it is 39. Yes, this one, this dimension I'm going to use. The next thing, what I'm going to use is this dimension. I will go from this point to the other side. Let's just go back from this point if you want so. From this point we have, with these, we have a thickness at this point, which is, let's say, 4.2, and just have drop down this thickness and this thickness, which will result this step to be here, and this I will just calculate that value, the first step in my part. I will just make it different, and I will just calculate from the back side of our part. Let's have this part. The dimension here, which is from the point here, we have 0.20, 4.20 minus or plus, we have 0.38, like this. The first thing, I will just add 4.2 plus 0.2 plus 0.38. With minus sign, I'm sorry, the minus sign, we have 0. I will just go 0. Again in parentheses, I will prefer plus with the sign, which is 0.12, which is this dimension. It is 4.345, which is from this point to this point. We will just drop down this point by addition from the bottom side. Please be careful. From the bottom side we have 4.32 here, and we have 0.3 here, and also we have some additions here. I'm just also, we can just calculate this one with minus this, which is the same in this level. Also, I will just change my formula here, and I will just drop down this value. I will omit the 0.50. Yes, 350. And this time I add 4.4 and with minus, I'm sorry, 4.4. Let's calculate again. 4.4. I will just delete all the formula. 0.4.4 minus 0.3115. Yes, it is 4.078. The next thing, we have this dimension. From this point we have 0.3
0.15 added to 0.20. Also, we can use this dimension to have this point here, 0.35 after this point. I will just use the dimensions. Let me just close a little bit and adding the formulas here. From this point I will just go to this point, and after that we have the threaded section up to the top side. From here I have 0.35 plus 0.38. We also have, let me look from here, 38 up to this point. We have the same, probably the same level here, and I think we have this retaining ring, which is 0.1 and plus 0.1. Yes, this one. And the diameter here, it is, as you see, we have 0.5 inches. Again, from the paint section we have 0.5 diameter. From this point we have just calculated our dimension. Yes, the next thing, we will just continue that dimension, again the same size. We can also follow that dimension again from this side, this one to this one, again 0.5. As you see, we all have the dimensions, but this is in threaded section, this is not threaded one. We have finished our sketch, have the revolve tool. We have one closed loop and one center line. It automatically grabs and create this our feature. And after this one, we will just add a threaded section here for the top side with ANSI unified with, as you see, we have dashed 13. Let me show you this designation here. We have 13 here. I will just go up and get this one. As you see, we have 0.5, but this time I'm not going to use the top side. I will just only use this portion, and this portion is about, from this point we have an height here. I'm just going to calculate here. As you see, we have 795 inches, and the other part we have this reference dimension, which is 0.620. I will just give the thread length from the top side with a limited, which is 0.620. Only one portion here. This is our shaft. And save, I will save this shaft with 3 shaft dimension. Yes, this is the shaft part here. Again, I will just extend my sketch here, and I will add this view. I'm just going to make close, and I will just create a new view for the shaft part for our technical drawing. Okay, I will delete this end. I will use this time only one view. It will be enough to create this view. Also, we have just missing part here. I will again turn back to this part by having this one open, or you can use the file and open section. We have a key missing up to this point. We need a key insertion, start a new sketch at this point, and our key dimension, which we have previously calculated. With this one, we have a square key, which is 0.25 in all cases, and we have a dimension, this line, from the back side of our part. For this, I create a geometry and make tangent this line to this curve or circle. Also, I will just create a line, construction line. These lines I'm not going to, or these circles I'm not going to use. I will only use this rectangle tool and make this rectangle tool symmetrical around this line, and I will just create the dimension which we have calculated before. It is about 0.693, I think, like this. 6, yes, and I will have a cut here. If you want, you can also use 0.1 through 5. We have the key dimensions here. I will just make the cut, extrude up to, with the selection to command, to up to the gear sitting point, which is at this surface. I will just make the all through cut with this geometry. I will turn back to the part drawing. Okay, we will continue our part modeling. This is our shaft part, and we again double click with this shaft, and I will just define a region for our shaft drawing, and I will just close, copy the definition and change to paste with this. This is my third part. It's a shaft, and it's not a sheet metal band part. For this, I will just create an axis line between two lines and retrieve the dimensions of my part. I will arrange the dimensions which I have seen here. I will use this dimension which I have defined. First of all, this is our shaft dimension, outside dimension. This is the dimensions which I have given, especially in the units of inches. The dimensions here have many decimal points and not rounded up. Your example will be rounded up. Here we have this one. Also these dimensions, I'm not interested in this dimension, I will just use this one. And I'm not going to use these two dimensions. Also, I need a sectional cutout at this point. For this, I will use a section and I will define for K dimension, I will just create a sectional cutout at this point. And I will move that sectional cutout with break alignment tool. I will just use this view somewhere here because I would not like to have a shape. I would like to just save space in my figure. I will use these tools a little bit, enlarge this dimension and have this tool. Also, we have, at this point I will just delete, I have a threaded feature which is at this point. I will just add the thread dimension. Let's use this one. These inside diameters here, which is this. It is the 0.5-13 UNC 2A with tolerances here. Here also we have a sectional cutout. I add an access point and I will just retrieve the model dimensions, which are the groove, key width and key height. Also we do not have any dimensions here, I'm sorry. Yes, this one. And we have the dimension, stick to this point. I will just extend, try to extend to get that relationship. And I'm not interested in this one because I can just define this dimension, this groove here with that dimension. Okay, we have this dimension, and if you would like to just make it in more detail, we use the detail view here. Select the view which we would like to add that detail. With one click, we just choose the far fence shape from this point and the cutout shape from this point, which we have a partial cutout here, for example. And I would like to have this detail with the B detail here, and I would like to have that B detail. If we want, we can just show this dimension with erase and get that dimension, that groove dimension, from the retrieve model annotations. Also, we can go back to the part, shaft part. We will again define the tolerance of our part groove dimensions by having the properties of dimensions with the tolerance type symmetric. This is not symmetric, this is the deviation with the upper size is 3 here, 003 here, and I will just add a dimension with the deviation of this. As you see, our dimension is not unilateral, bilateral this time. I will get this information. This is all our for shaft drawing and dimensions. I will just save all the files. This is also in sketch mode. I'm just going to make and complete my part file. we will continue the next assemblies for our parts. Okay, the next part we are going to design a gear set which we are going to use in our assembly modeling. We have two gears, as you see on the screen. We have a gear which is the bigger one. Also we have a smaller gear which is called the pinion gear, and we will just create these gears in the inventor environment. For creating the gear set in inventor environment, we are going to use a new, this time we are going to start with the assembly modeling. I get the standard millimetric, standard inch IEM, and just create one assembly. After creating this assembly, I will just go to, this time, not the assemble model, I will just go to design model. And under this tab, we have many machine elements that we can use and design for our purposes in the assembly environment. We are interested in the spur gears. We have 3 sets. We have one spur gear, not these bevel gear or worm gear or bevel gear. I'm going to just design a spur gear. After this one, you may have a warning to save your assembly files, because it will be also an assembly. Save your files with a gear drawing, gear set for assembly. The next thing, we have a dialog box open. Please enlarge the options here. Okay. Here we have the result window. This is our input window. We have information window at bottom side. Also we have a calculate and approval buttons here. Also we can just change our calculation methods for strength calculations. We are not going to deal with this one. I'm only interested in the creation of the gear set, which I'm going to use in the crane winch section. Here in our winch assembly, we have 2 gears here. One with this definition. If you look this definition, we have the N number, which represents the teeth number of our gear. Also we have, again, on the pinion side, we have 10N. This means that we have 10 teeth on the pinion side and also 50 teeth on the gear side. We would like to just make our inputs according to this number of teeth. We will just define our teeth. The first, we have 2 boxes, 2 sets here, the gear set 1 and gear 2. Also we have the guides, which we are going to just design our parts. I have just made them before this one, and these are the components that we can just enter the values to these sections. Also, I have a design guide which tells us to have the center distance, which was specified in our technical drawing. As you see, we have a center distance between the gear sets, and we will just set that distance by a number which is called diametral pitch dimension. As you see, I have just made some adjustments about this one. First, I have entered the number of teeth here. The gear set is the first gear, and gear 2 is the pinion gear, and it has the number of 10 for pinion and 50 for gear set, which was implied in the technical drawing. As you see, we have N, and also we have 10 for pinion side. The next thing, I'm just sorry. This is, if you want to design an internal gear, you have to select this section, but our gears are touching from the outside to each other. We have tangent external gears. For here, I will just make a diametral pitch adjustment by trying an error. You can just make, for example, if we select the diametral pitch and hit the calculate button, as you see, we have some design failures about the gear dimensions. Also, I will just add this dimension and calculate to have the right dimension. Also, we can just make some smaller dimensions, which is this one. I can just, as you see, the center of distance increases since the diametral pitch is increased. Let's change the diametral pitch dimension for our gear set to 8 millimeters, which we will get a center distance for 375 inches. After this one, we will just decide our face widths, which we have in the technical drawing. Here on the top view of our assembly, we have a gear set width here, which we will define again. This is the pinion gear set size, and also this is the pinion side. We have all the same width, which is 0.315. Also the face width for the gear set 315. Also we have another parametry for our gear set, which is called the pressure angle here, which is for both our 20. It must, because it's a meshed gear, and our pressure angle is 20. When we hit the calculate button and we do not see any warning at this section, and we have the results reasonable, we hit the OK button, or we can just define our component, stick to some points. For here, I would like to have my gear set assembly. This is because this is an assembly. I would like to have the first gear cylindrical face will be on z-axis, and the cylindrical starting plane I need to have on YZ plane by selecting this one. When I have just select this one, select the cylindrical face, the gear component 1 is set to this one, and the gear component 2, which is the pinion this time in our assembly or in our example, we have the same gear set adjust to this big gear on our assembly. When I have just calculate and with OK section, it just warns me about the gear sets to just save these one. If you want, you can change the names. This is the gear. Let's change their names and save this one. And the second one, which is the spur gear set 2, and I will just change that name to pinion gear. If we need changes, we will go back to this assembly, this gear set assembly in our part assembly, and we will change the parameters from this spur gear components generator. When I have just click OK, our assembly will be saved and the gear set is created. Here I would like to have, I have this feature which is a spur gear set, and as you see we have the spur gears, and we also have saved this spur gears in the in our folder side. We can also find out those gear sets. Here, if we need a change in our parameters, or if we have to change our parameters, we just go to this section, and with right click we just edit using design accelerator feature to get that dialog which we have created our gear set. Okay, we have our gear set, and we will continue for the modeling side of the drum weld assembly. I'm going to tell after this one. We will just use these two gear sets by creating the models here, and I will just, for example, if we want to make changes about these gear sets, we will just go open them like this. I think it's going to be opened, the part file. This is our part file. As you see, we just get out of the assembly mode, and we will just do the operations on our parts. For example, I would like to just cut out this body shape inside. I will just create a flange here, flange, and make this with cut extrusion processes for need. This time I need a sketch on this one, and I will just create a circle to cut here. And from the top side, for example, let's make our first gear for the other assembly. We have, as you see, I will take my mouse back. This time our ring inside, yes, this time our ring inside here with 5.6 inches. As you see, the gear inside have 5.6 inches. For this I will just adjust my geometry with 5.6 inches and finish my sketch. Have the extrude tool with cut through all option. Now I have the ring gear which I have seen in my assembly. When I just save my part here and turn back to this gear, as you see, our assembly gear set is just again created. I will just select and save all the things. For the other parts, let's do the same thing. For same operations here, we have a gear set with open the pinion gear. This time we have a hole and a case set like this. For the case set here we have a rectangle tool. I will just make this rectangle symmetrical around this line, and our K was 0.125. Also this time 0.125, and it is just symmetrical I will first make this one tangent to this curve. I'm not going to use this one, but I would like to have this line symmetrical on this line. I will make the midpoint coincident to this line. Also, I will just again create the hole for my actuator shaft, and at that actuation shaft here we have the dimension, as you see, 0.5 inches passing from this shaft size, 0.5 inches. I will just make this and just make the cut in all sections. I would like to have a keyway cut with a hole. I'll change it through all, only cut the hole, and this time I have created my pure gear sets. I'll just make this one, and I'm going to use this set in my part assemblies. Okay, this is all for our gear set assembly, and I will just continue with the first drum welded part.